Hi, in this video I'm going to give you an introduction to linear systems, and I'm going to do this by showing you an example. So this is a problem about some of my friends. They have chickens out in their backyard, and then they sell the eggs from the chickens. So they sell two different sizes of cartons. The large cartons, which I guess are just regular 8 cartons with a dozen eggs, and they also sell small cartons because some people only want half a dozen. Last week they sold 35 cartons of eggs, and altogether that was 360 eggs. So the question is, how many of each did they sell? This question, I'm using this question as an introduction to linear systems. It's a relatively simple question. We could do it just with trial and error. We could guess a number that would add up to 35 cartons and then see how many eggs that was total. And depending on whether the number was too big or too small, we could use more big cartons or more small cartons. But we're going to develop over the next few weeks different ways of solving linear systems, so mostly algebraic methods and also some graphical methods, and these methods are going to be really, really powerful. So we're going to start with easier examples like this, but it's to slowly build up, and then by the end of the unit you'll be able to solve really difficult problems. So as I go through this, you may think, oh, that's kind of silly, I don't need to do all that work to answer this problem, and that's maybe true. But the point of doing this work right now is to build up the skills so that you can answer really difficult problems. Okay, so this first question asks us to represent this situation with a system of linear equations. So what a system of linear equations is, it's more than one linear equation. For this year we'll mostly be looking at 2. That use the same variables, so if one of them uses x and y, the other one probably uses x and y as well. And then we're considering them at the same time, they're part of the same problem. Okay? So if we're going to represent a system of linear equations, our final answer down here is going to be 2 linear equations. We have to choose some variables first. So the way we choose the variables on this is we'll think, well, what are the things, often the variables are going to be what we're trying to find, which in this case is how many of each did they sell, so how many big and how many small. Or the variables would be the things that you know a little bit about, like we know that they're selling large and small cartons, but we don't know how many of each. So usually those will be the variables, and with practice you'll get good at choosing efficient variables. So in this case, my variables are going to be the number of large cartons, which I guess I'll call L for large, and then the number of small cartons. So this is how you explain this. You write let L. I'm going to do a cursive L, just so it doesn't look like the number 1. Represent the number of large cartons and then I'm going to let S represent the number of small cartons. If you want to use x and y, that's perfectly fine. The advantage of using L and S is that I don't forget which is which. Okay, and then there's some information we know here. We know that they sold 35 cartons altogether. And then we know that that was a total of 360 eggs. But this 35 is the easier thing here. This is going to give us total number is the large plus the small is equal to 35. Because my total number of cartons, large and small together, is 35. And I'll give this guy a number. I'll call that equation 1. Just so, because in a minute I'm going to have another one, just so I can refer to them. Okay, the other information is that there's a total of 360 eggs. Okay, something is going to be equal to 360. Now some of you may know right away, and if you do you can sort of fast forward this next 30 seconds or a minute. But let's just look. I'm going to make a little table over here with some examples. You can always sort of do this if you're not just quite exactly sure what the equation should be. Just kind of work on some examples and look what the numbers are like. Suppose they had, I don't know, maybe sold 4 large cartons and 8 small cartons. The total number of eggs, well, my large cartons hold 12, so it would be 4 times 12. And then the small cartons only hold 6, so it would be 8 times 6. And that's 48 plus 48 is 96. Okay, and then maybe if we sold 10 large cartons and 5 small cartons, the total number of eggs would be 10 times 12. Because that's, if we got 10 cartons with a dozen each, that'll be 10 times 12 eggs. And then the small cartons, there's 5 cartons and they've got 6 eggs each. So 5 times 6 would be how many we've got there. So that's 120 plus 30 is 150. So this sort of helps you get an idea of what's going on when we're going to look at calculating the total. With practice you may not need to do it, and if you don't need to do it, that's totally fine. But if you're not quite sure about what the equation should look like, then just do some examples. So what we're doing each time is we're taking the number of large cartons and multiplying that by 12, and then we're taking the number of small cartons and multiplying that by 6. So in this case, 12 times the number of large cartons, we don't know how many there are, but we have a variable for it, so it's just going to be 12L. And then 6 times the number of small cartons is just 6S. So 12L plus 6S equals 360. We'll call that equation 2, and that represents that there's a total of 360 eggs sold. Okay, part B here asks us to verify that 25 large cartons and 10 small cartons is a solution, first of all, to the problem about my friends and their eggs, and second of all, to the linear system. This here is the linear system. We can also call that a system of linear equations. Okay, so check that it's a solution to the problem. So first of all, things we know is total cartons, 35. So the cartons, and they're claiming that 25 large and 10 small is the solution. So the total is 25 plus 10. That comes out to be 35, and that was what we were supposed to have. So check mark, that part is right. And total eggs. So 25 large is 25 times 12 eggs. And then 10 small is 10 times 6 eggs. 25 times 12, that's 360, so this is 360. And that was how many eggs we're supposed to have. So this makes sense. This is an answer to the problem. Now to verify that this is a solution to the linear system means it's actually the same thing, but it's a little bit more precise in terms of form. What we're going to do is we're going to show that L equals 25 and S equals 10, that these two numbers, if we substitute these into these equations, both of the equations will be true. Okay? Now there's a little bit of a I guess of a sort of formal way we have to do this a little bit, because we don't want to just substitute in and say that this plus this equals 35, because sometimes you'll have to verify a solution that isn't true. You'll say check that this, or you'll solve the problem yourself, but you will have made a mistake. And if you just say that things are equal, then on your next line you might have something like 27 equals 35, which is not true at all. So the way that we like to do this is we sort of work with one side at a time. So in equation 1, the left side, so left side, LS here stands for left side, everything up to the equal sign. So the left side is L plus S. Okay, and if I substitute my L and my S, it's 25 plus 10, which is equal to, that's 35. The right side of the equation is, well, that's just 35. In this case, we didn't have to even do anything there. And so that is equal to the left side as well. So the left side and right side are equal. And that means that this is the solution to the equation. Because if you substitute the numbers in, the two sides come out equal. Okay, for equation 2, the left side is 12 times L is 25 plus 6 times S, which is 10. And that's 300 plus 60, and that's 360. And the right side of the equation is 360, and that's the same as the left side. So that's the same as the left side. So the right side and the left side are equal when we substitute those numbers. Okay, so to review here, a system of linear equations is two or more linear equations that we're considering at the same time. They're part of the same problem and they use the same variables. And then to verify that certain values are a solution to a system, you substitute the values into the left side and figure out what that comes into. And then substitute in the right side. In this case, we didn't even have to substitute. And then if the two sides are the same, then that's a solution. And for these values to be a solution to the whole system, they have to be a solution to both equations. If we had 3 equations, they'd have to be a solution to all 3. Okay, so there's a little introduction to linear systems.